tengo el paquete.
I've got a visual in here.
Okay, I'm connecting you guys to the system.
Seriously, these techniques are usually not used like this. They're actually more commonly used by scientists to study animals.
That's right. Animals are a lot like humans. If you want to study their behavior, you have to know what they're doing. But you can't see them all the time, and sometimes you don't want them to see you. So to get around this problem, we're turning to remote sensing techniques.
There are lots of reasons to study animals. One might be for conservation. For instance, you might study the movement of fish to know where to set up protected zones. Also, some animals are vectors for pathogens. If we know their behavior, we'll know how to protect ourselves. Some animals give insight into human behavior. And animals interact with their environment. So it's important to understand how they do it. So that brings us to the rainforests of Panama.
In the forest, many trees produce seeds that drop to the forest floor. These seeds are then dispersed by animals. In much of the US, squirrels help disperse seeds. In Panama, there's an animal that disperses seeds like a squirrel, but it's actually a relatively large rodent called an agouti.
All right, so if we want to know everything there is to know about agoutis, like when they eat, when they sleep, and when predators like to eat them, how would we do it?
There are many ways to study animal behavior. You could directly observe the animals. You could use remote video cameras. You could walk around with radio telemetry instruments. You could even use satellite tags. Or on this one special island, you could use a system called ARTS.
It stands for Automated Radio Telemetry System. The main purpose of the project is to be able to monitor animal activity 24 hours a day, 7 days a week. Since there are so many individuals out there in the forest, we want to look interactions between individuals of the same species and individuals between different species. Well, the advantage is that you don't have to be actually out there in the forest to track the animals, so you can do it 24 hours a day. And for animals that are active at night, it's easy for you just to be there in the lab and just watch how the signal changes. It's kind of hard for you to go out in the forest in the middle of the night. So that's very important, and because also gives us an activity pattern of the animal all the time. With the handheld antennas, you don't have that. So in the top of the tower, we have basically an array of 6 antennas, which work exactly the same as the ones here. And what we do is that we record the signal strength from all the antennas, and then we take the 2 strongest antennas, and from there, through an algorithm, we estimate a direction. So with a single tower, we only get a direction of where the signal is coming from. You need at least another tower in order to get another direction, and then you can triangulate. So we use the system and manual radio tracking as a complement of each other. We have tracked ocelots, capuchin monkeys, holler monkeys, agoutis, sloths, bats, orchid bees. We want to understand how the whole ecosystem works. So, for example, the agouti-ocelot interaction.
What are you studying there with the agouti and the ocelot?
Basically the prey-predator relationship. There's the ocelot, agouti, and there's also the agouti seed. So these seeds are the main diet of the agoutis, and we want to know how these seeds are dispersed through the forest. What the fates of those seeds. So an agouti picks it up, he might eat it right away, or he might take it and hide it somewhere else to go there and eat it later. We want to know why this happens. Why is he doing this? And then what happens to the seed? What happens when the agouti is being eaten by an ocelot? What happened when the agouti dies? What happened to this seed that he buried? Is it going to be a new palm out there in the forest, or is it going to be taken by another agouti? We want to see how this dynamics works.
So we've learned how remote sensing techniques can be used in many ways to study animal behavior.
That's right, and studies like the ART system, which study agoutis, are helping to determine just how important they are in the functioning of this ecosystem.
Now remember, you don't need any fancy equipment to study wildlife. You can just do it with stuff in your backyard and around your house.
So until next time, we encourage you to never stop exploring your world.
So I hope you enjoyed the video. It's one of the many videos that go with this high school biology textbook from Pearson Publishing. Check out more about what we're doing with them at this link right here. Okay, stay tuned for more to come.